Hey everybody, welcome back to Math 10C. We are going to start our actual learning today. So this is our first day of online learning in 10C. I'm Mr. Henry and I'm going to be teaching all of you guys. A couple clarifiers and maybe some more details about what we're going to be doing. Last week I shared what you need and what you can expect every day, and I said up to an hour of work time. That's the long shot. A long day is going to be your dedicating a full hour to Math 10C. I would say on a normal day to expect somewhere between 30 to 45 minutes, and that will include watching some videos, attempting some homework, looking up online resources and stuff like that. If you're willing to commit 30 to 45 minutes a day, this is going to be a success. Okay, things will progress as the course progresses, where we look at new online resources, we look at going live, we look at joining group chats and things like that. For now, it's going to be simple. It's all going to be based around Google Classroom. We're going to post some videos and go through some lessons. And then as well today, I'll also show you how you can ask me questions and what's the best way to have some communication between us. So to start, what you're going to need is your AVP workbook. And we're going to go through a lesson today, and then I'm going to give you some homework. And it'll probably be around that 30 to 45 minute mark. So I'm going to jump to my lesson, and you are going to open your workbook, and I'll show you what page we're going to do that on. Okay, we are in our workbook on page 265, and the unit we're going to start with is polynomials. If you were in my class before this, we've already covered a lesson or two of this, so you guys are going to get to revisit that, and then we'll move on to some new stuff. Everyone else, you'll be seeing polynomials for the first time this year. Everyone has covered trig and powers and roots, so we're all in a very similar spot. Okay, polynomials is something you covered in grade 9. What we're going to do today is review that, add a few details, and get ready to move on to some new stuff. So polynomials expands, we get more and more complicated problems, and then we get to start looking at things in a different way. Then we've got the blurb in your workbook here. In this unit, we study algebraic expressions called polynomials. We review the classification of polynomials, addition and subtraction of polynomials, and multiplication by a monomial. We introduce the product of two binomials, so that'll be new, and extend this multiplication of polynomials. We will also solve problems involving polynomial expressions. Polynomials are great because they allow us to represent something with an unknown quantity, and that's the variable. Okay, so that's what it's going to talk about down here. In algebra, a letter that represents one or more numbers is called a variable. And all that means is it's something I don't know. Okay, maybe the value I'm talking about is 7. Maybe I could make it 8. Maybe I could make it 25,000. We pick X or A or Y, or we pick a letter, and that says, hey, this could be anything. And it doesn't matter what it is because I have a polynomial expression to represent it. Okay. Down below, 2a minus b plus 4 or 5 over x plus 3, those are called algebraic expressions. Okay. Yeah, algebraic expressions are called polynomials as explained below. So algebraic expressions, that's kind of an overarching term. We are specifically talking about polynomials, and there are specific rules to those things. So the building block of a polynomial is a monomial, and we'll expand on that later. Is a number or variable, or the product of a number and variable. And then it says, note the exponent. The exponent of any variable must be a positive integer in the number of a monomial. Okay, positive integer, we're going to come back to that. So what that means is on any of my variables, my exponent needs to be 1, 2, 3, 4, 5, 6, 7, 8, so on and so on, and we'll talk about that later. Then you've got a bunch of examples of monomials. The number that multiplies the variable is called the numerical coefficient. Yeah, coefficient, we had that in powers and roots as well, so that's a word we're familiar with. And here is where we get to polynomial. A polynomial, that's the whole unit, is a monomial or sum or difference of monomials. So I'm adding or subtracting a bunch of monomials, and you've got some examples of them below. Okay. Then it says explain why 5 over x plus 3 is not a polynomial, and this is something we're going to do more of as well. The issue comes from the x in the denominator. Having a divide by x, that part right there, and this is why we did powers and roots first. If I wrote that with the x in the numerator, it would have an exponent of -1. And up above, what we said was my exponents have to be a positive integer. -1 is not a positive integer. So this is not a polynomial because of that negative exponent. If I had a decimal as my exponent, it's no good. If I have a negative as my exponent, it's no good. If I have a fraction as my exponent, it's no good. Polynomials, we're only talking about those positive integers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, so on and so on. Okay, let's get to some naming. A polynomial consists of one or more terms which are separated by plus or minus signs. I'm adding or subtracting monomials. If I have one term, like just 4x, yeah, that's a monomial. As soon as it's something plus something, x plus 4, that's a binomial. Just like a bicycle has two wheels, a binomial has two terms. Trinomial, well, a tricycle has three wheels, a trinomial has three terms. X squared plus x plus 4. And then a polynomial is anything that has four or more terms. So polynomial is all of these, okay? But then I get more specific terms. So a monomial is a specific type of polynomial. Binomial is a specific type of polynomial. Trinomial, specific type of polynomial. They're all polynomials. I just give it a specific name. Just like you could have all sorts of vehicles, but maybe I call one a truck, maybe I'll call one a car, maybe I call one an SUV. They're all still vehicles, but I have specific names. So all of these are polynomials, but as soon as I have four or more terms, I run out of special names, and I just call it a polynomial. Okay, now let's get to some actual questions. It says, consider the following algebraic expressions, and we are going to decide, are these a polynomial or not? And then you're going to tell me why. Okay, so I'll go through these. 1/4 x, y, minus 10. All I'm looking at is the exponents. I can have any coefficient I want, but the limiting thing is an exponent. These, and we'll come back to this later as well, have an exponent of 1, x to the 1, y to the 1. That's great. Not a decimal, not a negative, I'm good. 3, p to the 1, q to the 1/2. That is no good. That is not a polynomial because of this 1/2. Move on to the next one. The root of 7x to the 4 minus x to the 3 plus 1. Maybe I would think this is not a polynomial because of that square root 7. And maybe I think I can't have square roots or something like that. I can have decimals. I can have square roots. I can have anything out front or as a coefficient. What I'm looking at is the exponents. And exponent 4, exponent 3. That one's good. That one is a polynomial. D. 3x squared plus 9x minus 4x to the 0.2. Yeah, as soon as you have that decimal exponent, you're no good and you have to move on. And finally, E, 7 over A. We already talked about that. You can't have a variable in the denominator. Okay, that's like having a negative exponent. So I won't see that. Those are things that I don't consider polynomials, and those are things we are not going to deal with in this unit. Moving on to the next page. Complete the following table. Okay, let's talk about a few things, and I will allow you to pause the video at a certain point here and try it on your own. 4x plus 3yz, that is my polynomial. I'm going to go through this table, and I'm going to categorize a bunch of things. And I'll give you tables like this. We'll do a few examples, and I'll ask maybe different things each time. This one I'm saying, how many variables are there? So how many letters are there? I see an x, I see a y, I see a z, I see 3 different types of variables. Number of terms. I think back to the start of this lesson. The number of terms, that was how many things are added or subtracted. I have 4x and I have 3y to the z. I have 2 terms. 2 things added or subtracted. And finally, the name of the polynomial. That's asking, another way I could say that is asking you to classify. So how many terms are there? There are 2 terms. The name for a 2-termed polynomial is a binomial. Okay, here's where I'm going to invite you to pause the video and complete the rest ahead of me. That'll give you a good way to see if you're on the right track, if you're doing them right. So right now, pause. And now I'll start up again. You had your opportunity. Try it ahead of me. I really want you to try it ahead of me. And now I'll go. Number of variables. 2a minus 4b plus c. There are 3 different letters. I see A, I see B, I see C. It also has 3 terms. 2a, negative 4b, and 7c. And the name for a 3-term is a trinomial. That's the special name. Okay, x squared plus 3x plus 4. I actually only have one variable, x. X is the thing that I would plug in. X is the only letter that I see there. I have 3 terms, x squared, 3x, and 4. So the name of a 3-term polynomial is a trinomial. There you go. Next one, number of variables, again, is 1. There's just the x. That's the only variable I see. Number of terms, there's only 1 term. So the name of a 1-term, that's a monomial. That's what we started the day with. 2x cubed plus 3x squared y plus 3y squared minus 8. Well, I have an x and I have a y. So I have 2 variables. In terms of terms, this one has more terms. You've got 2x cubed, that's a term. 3x squared y, that's a term. 3y squared, that's a term. And negative 8. So 1, 2, 3, 4 terms. Well, this is above my realm of specific names. I don't have a specific name for a 4-term or a 5-term or a 6-term. We just call this a polynomial. Oops, spelled that wrong. I'll write over it. Okay, and again, I'll maybe remind you, these are all still polynomials, binomial, trinomial, monomial, but they have a specific name. They're still polynomials, I just categorize them differently. Moving on. Classifying polynomials by degree. This is something from grade 9. We are going to add to our definition. So this is a bit more detailed. It's a bit more complicated than grade 9, but we'll pick it up and we'll see lots of examples. The degree of a monomial is the sum of the exponents in its variable. So it's saying what is the highest variable we have, or the combination of the highest variables we have. So 2x to the 5, there's only one exponent. It's a 5. So this thing has a degree of 5. The next one, I have a bunch of exponents. I've got c squared, I've got b cubed, and I've got a to the 1. And it's important to remember a variable has an exponent of 1. If it's not listed, we know it's 1. Okay? So altogether, the degree of this thing would be 1 and 3 and 2, or if I add all of those up, 6. So if I have multiple variables in a term, in a monomial, I can bind their exponents. That would be new from grade 9. That's something you might not have seen yet. Okay? If I'm now talking about an entire polynomial, I find the degree of each term, the degree of each monomial within it, and I pick the highest number. So within this one, 3x squared y squared, your first term has a degree of 4. Exponent of 2, exponent of 2. That thing has a degree of 4. The next one, 2x to the 4, there's only one exponent, but still, it's a 4. Next one, you have x to the 1, y to the 4, all within a term, so that would have a degree of 5. And minus 2, and this is something it says below, I'll say it here, a constant. If there's no variable piece, there's no exponent piece, so it would have a degree of 0. So I go through the polynomial and I say, well, what is the degree of each term? And then I combine it and say the highest of those numbers is 5. So individually I add it all up, but then when I'm finding the degree of a whole polynomial, I just pick the largest number. And down below it says the polynomial has a term of degree 0 if there is no variable present. And that is called the constant term. A term without a variable we call the constant. In that polynomial we just did, the constant is negative 2. And the reason I specify negative 2 is because it was a subtraction. If it was plus 2, I would just say 2. But whenever we have subtraction, we need to state that as the negative and write that in our constant. Okay, moving on. Give an example of these things. So here's where there are a million answers to this. And this is another opportunity where I tell you to pause and try these ahead of me. And then I'll quickly throw some examples out. But you can absolutely pause and try ahead of me whenever we're doing this. So a binomial of degree 1 in one variable. Okay, well, a binomial, so I know I need 2 terms, like maybe an x is 1, and then maybe a plus 3. And degree of 1, yeah, x has a degree of 1. Okay, it would be written right here, but I don't have to write it. We know it has a degree of 1. And I'm only allowed one variable, so I couldn't say x plus y. I had to say x plus a constant. I had to put something else. I couldn't put another variable. Okay, and there's an infinite amount of examples you can give, and that's just a simple one. A trinomial in 2 variables with a constant term. Doesn't say anything about degree, so I could do whatever I want for degree. Maybe I say x squared minus, and now I'll put in a second variable, y to the 4. And then it says I need a constant term, so I'll go plus 7. Okay, again, a million. A monomial of degree 6 with a numerical coefficient of 9. Coefficient's the easiest thing. I just write a 9, then I start my variable. I'm not allowed any plus minus, okay, but I could have potentially, 2 variables, or I could even have 3 variables. The only thing I need to worry about is getting to the degree of 6. So maybe I say it's x to the 3, z squared, and y to the 1. If I add up those exponents, I get to a degree of 6. And again, many options. A binomial of degree 8, each containing 2 variables. I'm going to stick with x's and y's because I'm not very original. xy, that's my first term, plus xy, that's my second term. Now I need to figure out the exponents to get that degree of 8. I'll make it in the first term. The second term doesn't matter. As long as I have one term with degree 8, the whole polynomial has a degree of 8. And I'll go x to the 5, y to the 3. Those exponents add up to 8. The other one, xy, doesn't matter. I can leave it as is. I could maybe make this x squared, y cubed. Doesn't matter. As long as it has a degree less than 8, this first term has already stated that the degree of the whole polynomial is 8. All right, moving on. Polynomials in a single variable. Polynomials in a single variable are usually arranged in ascending or descending order of the powers of the variable. Okay. Ascending really doesn't appear that often. Descending order. And when I say descending, what I mean is descending degrees. We order our polynomial with the highest degree at the start and then the lowest degree at the end. The next little detail, the leading coefficient of a polynomial. The leading coefficient of a polynomial in a single variable is the coefficient of the term with the highest power of the variable. Or if I write it in proper order, it's the first coefficient that I see. So consider this polynomial. Write it in descending order of powers of x. Well, maybe to start, I rank all the degrees. 2x, that has a degree of 1. 4x cubed has a degree of 3. Negative 7, that's a constant that has a degree of 0. And 6x squared over 5, that has a degree of 2. So I'm going to write this in the proper order with the highest degree term first. And I need to remember that the coefficient will come with it. So my highest one is degree 3. And that was subtract 4x cubed. So the way I'd state that is with the negative 4x cubed. My next term was plus 6x squared over 5, so positive plus 6x squared over 5. Now I have the degree of 1, which was 2x, and it's not stated, but I know it's a positive 2x. If it was negative, it would have a negative sign out front. If it does, then I know it's positive. That's where I'd fill in the plus 2x. And finally, I can end with my constant, minus 7. So if I arrange a polynomial properly, the constant always goes at the end. We are not going to write it in ascending. That I might ask you to do, but you can do that. I'm more focused on writing it the proper way. The way we would write all of our final answers, the way we organize our work is descending degree. State the leading coefficient and constant term. The leading coefficient, that was the coefficient on the highest degree term. In this case, it's the negative 4. X cubed has the highest degree at a negative 4 out front. My constant term, that's the thing without the variable, negative 7. Okay. And then it asks, just an aside question, the numerical coefficient on the x squared is you have a multiply by 6, you have a divide by 5. I can represent that in fractional form, 6/5. I have a 6 on top, I have a 5 on the bottom, just like I did on x squared, written as a single fraction. Okay, that is talking about these, working our way through these. The next thing we are going to do, is refresh ourselves about algebra tiles. Okay, I'm going to interject here, and that's where I'm going to end it for today. Maybe a little bit on the shorter side, but it's definitely not the most exciting lesson, so I wanted to work on some other things. So I will quickly explain what I need you to do for homework, and then I'm also going to show you in a different video how you can ask me questions for homework and how we're going to go with that process. So there's a little bit of housekeeping to take care of today. It's not the most exciting lesson in the world, I know, so that's why I'm going to do some other stuff to occupy our time, and then tomorrow we'll move on to some new material, some refreshing of things, and launch into polynomials even more. Okay, I'll quickly explain the homework and then go to the other video. And here is your homework. We're going to jump ahead to page 269 in our workbooks, and you can do 1 to 5 and 7. These are all really quick questions about categorizing or labeling, so I don't think this will take us too much time. And as I think you're probably aware, if you flip a couple pages ahead to the end of the assignment, the key is there for you to check your own work. So that's what we'll do. That is it for me. I will wave to you guys, send you away. I'll make another video about how Google Classroom can be used to ask questions and different things like that. But other than that, I hope you enjoyed the video. I promise my videos will get better as we move forward. I'm learning this as well. And attempt the homework. Let me know if you have any problems, and I will see you guys again tomorrow.